Okay, we start with concave lenses today. Okay, concave lenses, very simple. You remember convex mirror? Convex mirror used to form only one type of image, which used to be an erect, smaller than object. Convex mirror means, remember your car mirror. You used to form a virtual, erect, and smaller than object. Buffalo can be seen fully, so it is smaller than object. Same thing will be out here. Okay, so we are studying for concave lenses. Concave lens. So let's first see what are the image formation rules. Pretty simple image formation rules for concave lenses. So this is my principal axis, and on my principal axis I make the lens axis. Very good. Then I will make my lens. What is the lens? The lens is concave lens. So I make my lens. Okay. Fine. Image formation rules. Then definitely I'll have a focus out here. And remember, we are doing for concave. So the F dash, the secondary focus is on the other side, not on this side. Okay. So image formation rules. I'm starting with the image formation rules. The rules are pretty simple. Okay. A ray. Now see, remember one thing. This is called a divergent lens. So it will diverge out the rays. And its main focus is on this side, not on that side. Okay. So a ray of light which is parallel to the principal axis, a ray of light which is parallel to the principal axis will appear to diverge out from the focus. Do you understand? Will appear to diverge out from the focus. What I mean to say is that it will appear to diverge out from the focus. So the ray will be in this manner. Have you understood this? So we can write this as number one rule: ray parallel to principal axis appears to diverge out from focus. Very simple. Second one also I will mutate in the same diagram, but I'll draw with a yellow color. Okay. I'll draw with a yellow color. So the second one is somewhat like this. Second one is somewhat like this. A ray directed at the focus. A ray directed at the focus, but it can't go to the focus, right? Becomes parallel to principal axis after refraction. Ray directed to focus becomes parallel to principal axis after refraction. Pretty easy. Okay. इसी का उल्टा है. So number two is, if the ray directed to focus becomes parallel to principal axis after refraction. Wow. After refraction. Understood? Very good. Very good. Very good. Very good. Third ray. Third rule I will draw with what color? I will use blue. Blue color. Blue. I am using blue. And the third ray rule is very simple. A ray directed to the optical center passes without any deflection. Okay, this is the third one. The third one is ray directed to optical center goes without or passes without any deflection. Tell me, children, are these clear? Very clear. In convex, we used to say ray parallel passes through the focus. We say ray parallel appears to diverge from the focus. Ray through focus becomes parallel. Here we'll say ray directed to focus becomes parallel. And the third, there and here both are common, which is ray through the optical center goes undeflected. Though both are focused, na? Focus means this is also focus. This is a lens. Lens has got both focus. This is the primary focus. Even Anvita, what you are trying to say, see, if the ray would have gone through this focus, then also it would have become parallel. You can even make that also. You can make a ray through this focus and that will become parallel. Always, one thing, I don't know whether you people have noticed or not, just look at the board once. Wherever the lens is more thicker, the ray will always bend towards that side. Imagine the convex lens. Convex is called what? Converging. A convex lens starts from a pivot or a point and slowly starts flattening out. So the rays also come towards the flatter side. Whereas if you see a concave, it flats out on this side. So the rays always follow the flatter side. So now next, when you study a prism is flatter on the base. The rays will always come towards the, because a convex lens is a combination of prism, half trapezoidal prism, ulta half trapezoidal prism, ulta prism. That makes it what? A convex lens. Socho, convex lens kya hai? Prism, half trapezoidal, and glass slab in the middle. Glass slab always it will go straight. Here it will always go to here it will go always this. Whereas your lens is what? Concave. Ulta prism, seedha prism. So it will always go towards the base. This is the logic. I am not sharing all these things because the Guru cannot release all mantras. He has to keep some mantra. Otherwise, Guru Sisya will become equal. How can I allow that? Anna? What happened, Shreya? You caught cold? Or is it the perennial nose irritation that you have?
It's everyone.
So this is another one which is the enemy of the environment. She consumes 1 kilo tissue papers per month. That means trees are being cut and chopped. अच्छा भाई साहब आगे बढ़े, हो गया? Rules for image formation of a concave lens. How can you be so slow? खाना नहीं खाया तुम लोगों ने? 100%. If I now audit, 5 people will say, sir, I just got up and attended the class. Chale, aage chale, shall we? Here there is only one image formation when the object is beyond focus. Only one. Okay? So, not great thing. So, we say image formation. Image formation. Image formation for whom, bacha? Image formation for concave lens. Concave lens. So let's make our diagram. First we make the principal axis. Then what do we make? We make the lens axis. Very good. Then what do we make? Then we make the lens. To make the lens we will do what? One on this side, one on this side. Very good. After that you will make your lens like this. Agreed? And then you will have your focus here. Right? Okay, now time to put my object. Object is always erect and I have put the object just outside the focus. Okay, this is my object. This is my object. बहुत छोटा हो जाएगा. So this is my object. So what are the rules? The rules are pretty simple. The rules say ray through the optical center will go undeviated. So let's make one ray through the optical center which goes undeviated. Very good. Very good. Then what? Then another ray which is parallel to the principal axis. principal axis. This ray will appear तो टेढ़ा हुआ है. Another ray which is parallel to the principal axis, this ray will appear to diverge out from the focus. So let us make it appear to diverge out from the focus. Means the ray is actually going in. The ray is going in this direction, right? You need two rays to intersect. You can never get two rays to intersect. So there will be intersection of one extrapolated ray. Observe. खाली बनाओ मत, देखो पहले. This is something new. Intersection of one extrapolated ray and one original ray. And then your image will be created here. But since there is one extrapolated ray, so the image will always be virtual. The image will be virtual. However, the image will be erect. This is your image. So let us name it. This is a bar. This is a dash bar dash. A dash bar dash. So no matter where you place your object, the image is a virtual, erect, right? And C, smaller than object. Okay, Shreya, just come a little bit closer to the mic and speak. Sometimes got you a little bit blurred. हाँ, बोलो बेटो फिर से. The image is placed. Object can be placed anywhere. We have taken it beyond for wherever you take. That example I'll give you. You just draw this one, and once this is done, let's take some common sense. Some common sense. All you kiddos who are spectacled, and it is not only you in my class, your friends, anyone in this universe, 99% of you wear convex lens. 99% of you wear convex lens. All you. At least in my class, all of you who are there, all are wearing convex. Sorry, convex bol raha hu, concave lens. Arey, how do I make these mistakes? All of you are wearing concave lenses. Wear concave lenses. All you kiddos. Now you ask yourself, you do read a book. You do see the far away your girlfriend also who is not girlfriend. Do you see anybody inverted? Common sense. Shreya, you got the answer. Anything that you see with your specs, do you see anybody inverted? No. So it's understood. And do you see anyone inverted on your car mirror? No. So the car mirror is a convex mirror which forms same type of image. And the concave lens forms the same type of image, no matter where you are. And if you want to just prove till others are writing, as I always say, take out your specs and put it on the writing. You will see the writing smaller. Yes. All the writings will appear smaller if you take out your specs and you try to read the writings like magnifying glass. आपको छोटे-छोटे दिखेंगे. ठीक है? We'll do problems. One more topic I'll cover. Though that topic is also studied in next chapter, but we'll cover it here itself. Is this understood? There is only one case. Okay. चले आगे. So all you children suffer from a disease which is known as myopia. We will discuss this later, which is known as nearsightedness. Nearsightedness. What does this mean? You are able to sight the near. You are able to sight near. And sight near means see near. Children, the problem you have in this age is you can read a mobile phone, but you cannot read the blackboard. My problem is different. I can read the blackboard, but I can't read the mobile. You cannot read the ORR signboards properly, but you can read the speedometer properly. When I open my specs, I can read the signboard properly. I cannot read. So this is called myopia. Myopia's correction is done using concave lenses. Concave lenses are also used in optical instruments. That's also there. But all you children are wearing concave lenses. Our next topic Related to this is something known as power of a lens. Power of a lens. All that you speak, I am minus so, that so. Power of a lens is said to be the reciprocal of the focal length. This is for any lens, huh, children? But the focal length should be expressed in meters, not in centimeters. In all problems that you are doing, you are getting the focal length in what? Centimeters. You should convert the focal length. Hey, Neil, sit straight. Sit straight. No, but you were not sitting straight. You are a grade 10 boy. How can your backbone not be straight? The focal length of a lens whose focal length is actually in meters. You have to first convert in meters. And then the unit of power of a lens is called diopter, D-I-O-P-T-R-E, and is mentioned as D, Understood? This brings us into some new discussions. Have you understood what is power of a lens? The power of a lens is defined as the reciprocal of the focal length when the focal length is actually expressed in meters. The SI unit for power of a lens is diopter and is written as D. So let's see something more interesting. Now let's say I have a convex lens. And I have a concave lens. Agreed? Okay. What is the F of a convex lens? Positive. So what is the F of a concave lens? Negative. This is understood, right? If that be the case, the power will always be positive because the reciprocal's power is always positive, right? Here the power is always negative. Like, let's say some example. If F is equal to 1 meter, then what is the power equal to? 0.1 diopter, because power is 1 by 1 meter, which is equal to how much? 0.1 or 1? 1. The power is said to be plus 1 diopter because the focal length is here. Understood? If F is equal to F is equal to 1 meter. I'm not writing minus 1 meter. If F is equal to 1 meter in this case, power is equal to 1 upon negative 1 meter, which is minus 1 diopter. Clear? This is Jaideep Das. He suffers from farsightedness. I can see far. So my power in my specs is plus 2.50, whereas your power will be something like minus 3.5 diopter. Minus 3.5 is very high power. So these are, your powers are in minus. My powers are. This is greater. That means the focal length will be smaller. It will be diverging out more. If this is greater, the focal length is smaller. Means in my case, rays are converged more. And that we will study in the next chapter, just for your understanding. Okay. Then there's one more thing, though CBSE does not ask, they have asked earlier, this is in grade 12, combination of lenses. So if you combine lenses, then focal length is not seen in your case. The combined power of the lenses are P1 plus P2 plus P3 plus dot 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 plus dot dot dot. Did you understand this? Pn. Suppose n type of lenses you are combining serially one after the other. 2 convex, 3 concave, again 2 convex, 5 convex, 4 concave. It's just an algebraic addition. Means you'll take care of the plus minus and finally you will land up in something. Say I am plus 2.5. With me there is somebody who is minus 2.5. Our combined will give a power of 0. Understood? I am 2.5 plus. There is somebody with negative 0.5. Combined power will be plus 2. It's just added. This is called combination of lenses. ठीक है हो गया? एक problem कर ले. Let's do one problem and then let's say goodbye to this chapter. Goodbye. Goodbye. Let's go. Let's go. Gentlemen, let's go. And sign convention, what is the care you need to take in such type of problems? The care you need to take in such type of problems is that the F is always, Acha, what is the care you need to take? The care is that the F is always negative. Understood? The F will always be negative, and the image distance U, the image distance will be what? Tell me what will be the image distance in this case? It will always be negative because the image is formed on the other side. Chaliye, एक problem कर ही लेते हैं from the book. It says, okay, an object is placed at a distance of, so it says, question is, an object is placed at a distance of, so we are dealing with object distance, right? Object distance is always U, irrespective of the type of lens, we will always take it as negative. The object distance, object is placed at 50 centimeters. 50 centimeters means we will take it as negative 50. Lens type. The lens type is concave. Okay, the lens type is concave. 50 centimeters. The focal length is 20 centimeters. The focal length is 20 centimeters, which is equal to F, and that should be equal to minus 20 because you are using a concave lens. Asked you, find the PNS. Find the PNS of the image. Understood? PNS means position, nature, and size of the image. So fine, we use our lens formula. Our lens formula is 1 upon F. Our lens formula is 1 upon F is equal to 1 upon V minus 1 upon U. Lens is E, so negative, and V means VIP. V comes first. So let's substitute, and right here, because V we have not defined, V is the image distance. Children, in this problem, the image distance must come negative. Yes or no? Yes. Let's see. Or we write 1 upon V is equal to 1 upon F plus 1 upon U. So we write 1 upon V. What is 1 upon F? 1 upon F is 1 by negative 20 plus 1 upon negative 50. So this becomes negative common 1 by 20 plus 1 by 50. 20, 50, one common term is 10, and 2 and 5 LCM is 10. So the LCM becomes how much? 100. So 1 upon V becomes negative 100. So this will become 50 plus 20, which is 70 by 100. So V becomes negative 100 by 70, 0, 0 gone. Then negative 7 ones are 7, 330, 7 fours are 28, 220, 7 twos are 14. Yeah.
The top part, how does it become
Oh, yes. How does it become 50 at the numerator? Good. Come se kam you all are awake. Excellent. So I say 1 upon V is equal to 100 at the LCM. So 100 divided by 20 is 5. And this is 2. Negative. Is it okay now? Okay. It should be 2 plus 5. So now you do it. So V is equal to 100 divided by 7. So how much is it? 7 ones are 7. Then 3, 0, 7 fours are 28, 220, 7 twos are 14, 660, 7 eights are 56. Then 440, 7 fives are 35. That means I can write my V is equal to 14.29 centimeter approximately. Right. So we have told what is the position. Nature, you know how to disclose. The nature will be what? Nature will be virtual and erect. And what about the size? The size will be smaller than the object. Had they asked you to calculate magnification, now you can calculate the magnification also. Size you should not say from your mind. You should actually calculate the size. So magnification is equal to, but the height of the size is not given, but we can still calculate. Magnification is equal to V upon U. So my V is how much? Negative 100 by 7 divided by 50. So divided by negative 50. So into 1 by negative 50. So this and this cancels. 52. So which is 2 by 7 means it is less than 1. So I write, since it is positive, the image is erect. And since the ratio is less than 1, so the size is smaller than the object. Is the logic understood? Share, did you understand or not? This one, this logic? Yes, very good. Power of a lens done, all done. So if they tell you, without touching a lens, can you find out whether it is convex or concave? A convex will always give a magnified view. And if I take your specs, choto choto. So with looking at the lens itself, you can say whether the lens is convex or concave. You can do that. In fact, if there is any grandparent in your house who is using bifocal, you know bifocal, the type of specs which has got a like this. Take out this portion is convex, this is concave. This portion will make you look bigger. This portion will make you look smaller. Yeah. But nowadays we wear lenses which are called progressive lenses, like my lens. Half the lens is concave, half the lens is concave. So automatically it adjusts to your vision. चले अभी ये सब बंद करें. All we are done with light. LAT is closing. I'm closing light, and LAT will be reopened in human eye and the colorful world. We now move to जोर का झटका धीरे से लगे electricity. ठीक है? And all you